Welcome back to SCMB 4212. So we're going to continue with our next set of topics. So this is actually a continuation of the previous topic. So I'll call it part 2B for general electrical system diagnosis. So in the previous lecture, we look at the types of test components that can be used for automotive electrical and electronic testing, and we define voltage drop. So what is voltage drop? And also we discuss about the steps being used to systematically diagnose a problem or to find a fault in an automotive electrical electronic system. So the diagnostic procedure that we went through includes first step being verifying the fault, collecting further information, analyze the evidence, carry out further tests to locate the fault. Once we find the fault, we fix the fault and we do further checking to make sure that the fault has been fixed. However, if we cannot find the fault, then we'll have to repeat steps 3 and 4 until the fault is identified. So as for this session, we're going to look at the fundamentals of electrical wiring, terminal and switching that's commonly used in electronics and electrical system in an automotive vehicle. Then we're going to define what is multiplex wiring system that is used in automotive electrical system. So when we talk about wiring, so when it's of a certain size or basically cross-sectional area and above, we usually would call it a cable rather than a wire. Okay, so cable usually in an automotive vehicle is made from copper strands insulated with PVC. So copper is preferred because it has ideal properties such as ductility and malleability, and PVC is ideal as the insulation because it has very high resistance, especially towards petrol, oil and water. So the choice of cable size actually would depend on the current that is desired or to be drawn from the system. So larger cable would mean you have smaller voltage drop, lesser resistance, but it will be heavier because of the weight introduced by having a larger cable. So to do this, to design or to determine the size of the cable, we'll have to find basically we need to know the cable length, we need to know the resistivity of copper, the cable resistance, and from there we find out the area. So there's one problem in this equation. Okay, resistivity of the copper is in terms of units ohm meter, area is meter square, and you have cable length meter. So if you do this, you will not get basically ohm, so means there's an imbalance in terms of the equation and there's a problem with the equation. So to correct it here, actually the correct equation should be RC length rho times length, means resistivity times the cable length divided by the area. So this is the correct equation. Okay, please take note of this mistake in the notes. So from here, we can then, once we have the information, we can then proceed to size our cable. Okay, so aside from that, we will need to use also the equation from voltage drop, which is based on the Ohm's law, which is IR, and then you can calculate your power or current based on power, means you use the equation P equals to VI and rearranging them to give you I equals to PV. Okay, so as an example here, okay, so we have a power rating for lighting circuit in a car. Let's say the power rating is 4.5 kilowatt and we have a supply of 220 volts. So based on, for example, IEEE rule, the voltage drop across the cable is only allowed to be 2.5% of the supply. And we know we need 10 meters of length, and resistivity of copper is given as 1.7 times 10 to the minus 8 ohm meter. Okay, so here be ohm meter. So find the size of the cable. So in this case, first thing is to determine the current that is drawn. So using the power rating and the voltage supply, we can calculate the current being drawn through the cable. So from here, we can then determine the voltage drop, which is the allowed voltage drop, which is 2.5% of the voltage supply, which gives us 5.5 volts. And using this, we use Ohm's law. Okay, we have V equals to IR. So to get R, you have V over I. So in this case, you have your voltage supplied or voltage drop allowed, means 5.5 volts, and the current being drawn. So means the cable resistance should be 0.27 ohms. From here, we can use the equation that was given just now to calculate the area of the cable. So means here we can size the cable. So the cable size using this is 0.63 millimeter squared. So 0.63 millimeter squared is a very odd number. So if you go to the catalog, So if you go to the catalog, for example, this is a catalog. So you can look at the cross-sectional area component. Okay. So if you look at the cross-sectional area component, you have 0.6 or 0.7. So after that, you need to know also the continuous current rating. Okay. So based on the previous value, basically means you know that the continuous current rating is 5.75 and 6 amp. Okay, so from here you have two choices, either you choose 0.6 or 0.7. So which one would be the better one, to go 0.6 or to go 0.7? So coming back to this one, okay, let's come back to this one. If we choose 0.6, so let's revisit our equation. So you have rho L over area. If you choose a smaller area, you increase the cable resistance. So, and then if you go back to your equation, so if resistance increase, you increase also your voltage drop, and our voltage drop is capped at 2.5% of your voltage supply. So which means that if we get anything lesser than 0.63, let's say choose 0.6, the area is smaller, will increase the internal resistance of the cable, which will give us a higher voltage drop, which might go beyond the allowed 2.5%. So from this case, choosing 0.7 would be the better choice as compared to choosing 0.6. Okay, so I hope that you're clear about the selection and how you relate back the voltage drop, the allowed voltage drop to your cable resistance. So moving on from here, so when we talk about wiring, so you have different color codes and terminal designations. So for example, you have the British standard system, you have the European system, and terminal designation system. So an example here is that for British standard system, it uses 12 colors to determine the main purpose of the cable, and tracer color to further define its use. For example, brown color and symbol N, it refers to main battery feed. Blue color, symbol U, headlight switch to dip switch, and so on and so forth. Okay. So for European system, there is no correlation between the European and British system. So this is something that you have to be clear. But they still use color and basically symbol to also define the destination and the use of the wiring. So basically you need to refer and know, okay, this wire is meant for what. And the next type is terminal designation system. So this is used in accordance to the standard DIN 72552. This system will enables easy and correct connections to be made on the vehicle, particularly for after sales repair. Means it's let's say if you decided not to go back to your manufacturer. Okay, so based on this one, then basically the mechanics will look at the color or the coding to know, okay, which wire is connected to what system. So the designations are not to identify individual wires, but are to define the terminals of the device itself. So that's the philosophy behind using terminal designation system. Okay, so for example, Ford Motor uses a circuit numbering and wire identification system known as the Function System Connection, FSC. So they developed this to assist vehicle development and production process. And for their case, they use earth wires, black wires as the earth wires. So different car manufacturers maybe would also use will come up with their own identification system. So there's no one type of system. So example of this FSC system is that you have 31SAC3A, 1.5BK and RD. So what's the meaning of this? So 31 here would mean earth connection based on DIN system. S means additional switch circuit. AC here means your headlamp leveling system. 3 means switch connection. A means it's going to be branch. Okay, so then you have after that basically size is 1.5, means the cross-section area of the cable is 1.5 millimeter square. Color black and red stripe. So this is the meaning of the FSC system. So function, system, and connection. So when you talk about wiring system, you can also refer it to as a harness design. You can use the term harness design. So modern vehicle actually tends to have wiring harnesses constructed in a number of ways. So the most popular one is to bundle the cables to be spirally wrapped in a non-adhesive PVC. The non-adhesive tape is to allow the bundle of wires to retain flexibility. So then you place the cables side by side and plastic weld them onto a backing strip. So then this will allow the loom to run in narrow areas behind the trim of the inner seal or under the carpets. Or occasionally you can place them in PVC tubes, which will mean it's harder to wear and it's waterproof if you use a suitable seal. So when you talk about harness design, the issues that can be commonly faced would be the layout of the wiring loom. So cable wires actually needs to be run as short as possible so that you can reduce unnecessary voltage drops. Loom must be protected against physical damage, and the number of connections should be kept to a minimum. You can use a modular design if appropriate, and you have to consider accident damage areas or easier basically areas where you have a higher tendency to have accident damage. Then you can also look at production line techniques. Okay, and then you can access or basically what we say, the last statement here is accessibility to the wire for repair purposes. It needs to be easily accessible. So typical wiring layout here, you can use the H type, which is the more common layout, and then you have 1 or 2 junction box as part of a fuse box. So H types here, you have basically forming a H. So the fuse box is either here or here usually, okay, at the junction. Then you have E type here. So for E type, most probably it'll be here. Okay, so this is the front direction. So means because having it here is going to be not very relevant, because this is easily, basically if there's any accident from the front, you will damage the fuse box here first. So that's why usually it will go here. Even from the rear as well, accident happens if someone knock you from behind, you'll knock this part first. Okay, so this will be the typical areas for your fuse box. Alternatively, rather than wiring, to save the weight, you can go printed circuits or PCB, printed circuit boards. So this reduces the amount and complexity of wiring, especially in cramped areas. And this is very commonly used for your instrument pack, means your instrument panel in the car, or what we say your dashboard of your car. So this allows the components to be supplied as a single unit, means easy to install as well. And it's constructed using a thin copper layer bonded to a plastic sheet. So this is an example of a printed circuit board for your instrument panel. So you have your printed circuit you can have electrical circuits for your speedometer, tachometer, warning lights, no charge warning lights, panel illumination light bulb, and other types of warning symbols or signals. So as I mentioned, or most of you are aware, you have fuses in your car, so to basically avoid overloading that will cause damage to your electrical components. So if overload of current occurs, the fuse will melt and disconnect the circuit. So there are 3 types of automotive fuses. So you have glass cartridge, ceramic, and blade type. So the blade type is the most commonly used one because of its simple construction and reliability against premature failure due to vibration. So fuses are rated with continuous and peak current value. The continuous current is the current the fuse will carry without the risk of failure. Peak current is usually double the continuous current. So you have continuous current, blade type, and then for different types of continuous current, it will be in different colors. And then for ceramic type as well, usually you use for a slightly higher current. So to choose a suitable fuse, you have to first know the maximum possible continuous current. Then choose the next highest rated. If you choose the next lowest, then there's a tendency of the fuse always breaking down. So you will always have to replace the fuse. Okay, if the continuous current of the fuse is too high, it will probably protect against a severe short circuit. However, if the wiper blade is frozen, for example, let's say your wiper blade is frozen, a large value fuse might not protect the motor from overload. So this is assuming that you are staying in a four-season country where you have winter, where it's going to be very cold and the wiper blade motor is frozen. So aside from using fuse, you can have circuit breakers. So usually this is meant for heavy vehicles or commercial vehicles. So a circuit breaker has the same rating and function as a fuse, but the advantage is that you can reset it, so you don't need to replace it, so it will not be damaged so easily. But this comes at a higher price. So this is usually made from bimetallic strip. Okay, so the latch mechanics will prevent the contacts to close again until it's being reset. So aside from that, you have terminations or wiring terminations. So terminations are available and developed from early bullet type connectors into high quality waterproof systems in use nowadays. So you can protection against corrosion, usually you apply grease to the pins to repel water, or you can use rubber seals to protect the terminals. So aside from that, you have multi-way connectors to employ a latch mechanism to prevent individual pins from working loose. For high quality electrical connections, usually contact resistance of the terminal must be kept to a minimum. So this can be achieved by ensuring a tight joint with a large surface contact area between the terminals. So by using these multi-way connectors, actually you can reduce manufacturing costs, which might basically be a problem to older vehicles. Besides terminals, or basically terminations of wirings, you also have switches. So switches usually will switch on and off the basically will give you whether an open or closed loop circuit or closed circuit. So there are two parts of it. So you have the contact and the mechanical arrangement, which moves the contact. So switches usually has to be resistant towards mechanical electrical wear, low contact resistance, no built-out surface films, and low cost. So the electrical life of the switch is actually dependent on the frequency of the operation, on-off ratio operation, nature of the load, amount of actuator travel, ambient travel and humidity, and most importantly, the vibration level. Okay, so with this, I'll basically end this recording for the first part of the session. So stay tuned for the second part of the recording.